You know that feeling? You're just drowning in AI buzzwords, AI this, AI that, and you're trying to work out what's actually important.
Oh, yeah, totally. It's everywhere.
We get it. So today we've done the heavy lifting. We went through this pretty dense document from the OECD, that's the Organization for Economic Cooperation and Development.
Right.
It's all about how they suggest we understand and categorize AI. We've pulled out what we think are the really key bits, the stuff that will give you a clearer picture.
Exactly, because AI itself, the term, it's become so broad, it's almost meaningless sometimes, right?
Mm-hmm.
For anyone trying to get a handle on it, it can feel like trying to grab smoke.
Mm.
What are the actual pieces?
Yeah.
So in this deep dive, we want to give you a kind of solid structure, a way to understand the different sides of AI.
A way to see past the hype.
Yeah, see past the hype and really dig into what's happening underneath.
And look, this isn't just some, dry academic thing. Even though the source itself, the OECD framework for the classification of AI systems, it was first written for policymakers, for regulators.
People making the rules.
Exactly. Think of it as the experts trying to build a common language. But honestly, there's some really useful, really interesting stuff in there for you listening.
Absolutely. Our mission today, it's pretty straightforward. We want to give you a foundational grasp of how different AI systems can be sorted out, based on their core features.
And this framework, it actually shows some surprising differences between AI apps that might seem kind of similar on the surface.
Definitely. Think about, say, a self-driving car versus an algorithm recommending videos to kids online.
Okay, yeah, very different.
Both use AI, right?
Yeah.
But the implications, the things we need to think about, they're worlds apart. This framework gives us a way to understand why they're different and what that really means.
Okay, let's get into it. So the OECD framework, it's built around 5 main dimensions. Think of them as like 5 different lenses we can use to look at any AI system.
Right, to analyze it systematically.
These are people and planet, then economic context, data and input, AI model, and finally, task and output.
5 big categories.
And when you explore them, they actually give you a surprisingly full picture.
Precisely. These dimensions let us go beyond just saying, oh, it's AI, to really understanding the specifics of this system right here. So let's start with the first one, people and planet.
Okay.
This one, it really focuses on the human side of things and, the wider impact AI has on the world.
So under people and planet, what are we looking at? The framework mentions a few key things. First, users.
Mm-hmm.
It acknowledges that, well, not everyone uses AI the same way. You've got your regular person maybe using a chatbot.
Right, the amateur user.
Then maybe someone trained on a specific AI tool for their job, like a doctor using AI for diagnostics.
A trained practitioner, yeah.
And then you have the actual AI experts building the stuff. And why does this difference matter? Well, it ties into things like accountability, right? And transparency.
Exactly. What level of explanation does each type of user need? Who's responsible if it messes up? The expectations are different.
Totally different for someone just playing with an image generator versus an engineer deploying a critical system.
Right. Then the framework looks at impacted stakeholders. This is a much wider group.
Okay.
It's anyone affected by the AI, directly or indirectly, not just the user clicking the buttons.
So if an AI makes loan decisions, the stakeholders aren't just the bank employees using it, but also the people applying for loans.
Precisely. Their lives are directly influenced. It could even be broader, affecting market competitors or society as a whole.
Which leads nicely into the next point, optionality. How much choice do people actually have? Can they say no? Can they challenge the AI? Can they undo what it did?
Yeah, and the framework maps this out. Different levels. Some systems you basically have no choice. Think maybe certain security screenings.
Right, you can't really opt out.
Others might let you opt out completely.
Hmm.
Then there are systems where you can push back, ask for a review, maybe try to correct its decision.
Like contesting a flagged transaction with your bank?
Kind of, yeah. And at highest level, maybe you can fully reverse the AI's action. This whole idea of optionality is not just technical, it's about power, isn't it?
Definitely. How much control does the user or the stakeholder actually retain? A system with zero opt-out, it just dictates things, raises big questions.
Huge questions about autonomy and who's ultimately in charge. Compare that to, say, a movie recommendation. You just ignore it if you want.
Yeah.
Much higher optionality.
Now, this is where people and planet gets really broad. It pushes us to think about the wider effects. The OECD even includes a sort of
Like a
checklist,
sample checklist, yeah.
asking about impacts on things like our fundamental rights, democratic values.
Which is fascinating. It forces a systematic look. Like, could this AI, say, used for resource allocation, accidentally create inequality?
Or could an AI used in news aggregation limit the diversity of information people see,
Yeah.
affecting democratic debate?
Exactly. Those kinds of second and third order effects.
Yeah.
It's not just about whether the AI works, but what it does to our society.
And it goes further impacts on well-being, society, the environment. The checklist touches on health, job quality, social connections, community engagement, even asks about how long these effects might last.
It's all part of that bigger push towards responsible AI development, isn't it?
Mm.
Building things that don't just optimize for profit or efficiency, but actually contribute positively.
Or at least don't actively harm.
Right, minimizing harm. The framework notes AI could help with big challenges like climate change, but it needs that careful thought up front.
Okay, and one last bit under people and planet. Displacement potential. The whole robots taking our jobs thing.
Sort of. It looks at the possibility of AI automating tasks people currently do. They categorize it high, low, or no displacement potential.
So routine, predictable tasks might be high potential.
Generally, yeah. Think data entry, maybe some basic assembly line work, whereas jobs needing creativity, complex problem solving, empathy, probably lower potential.
But the framework is careful to say high potential doesn't automatically mean the job disappears overnight, right?
Exactly. It's way more complex than that. Involves economics, how companies adapt, retraining, but it definitely prompts thinking about the future of work and what skills matter.
Okay, that's a lot under people and planet. Let's shift gears. Dimension 2, economic context.
Right, so this is about the real-world setting. Where is this AI actually being used?
First up is the industrial sector. Finance, agriculture, healthcare, transport.
And the framework uses a standard classification system, ISIC REV4, to be precise. This helps compare AI adoption across different parts of the economy.
Because the issues in using AI for crop monitoring are pretty different from using it in high-frequency trading.
Totally different risks, different regulations needed. Then there's the business function. Where inside an organization is it used?
Like sales.HR logistics, R&D.
Exactly. And the same type of AI, maybe a prediction model, can have really different policy implications depending on whether it's predicting sales versus predicting employee performance.
Yeah, using it in HR feels much more sensitive.
Definitely. Then business model. Is it for profit? If so, how does it make money ads, subscriptions, selling the tech? Or is it nonprofit, public service?
And that matters because...
Well, the underlying model shapes the AI's goals. An ad-driven social media AI is designed to maximize engagement, keep you scrolling.
Right, to serve more ads.
Whereas an AI in a public hospital might be optimized purely for diagnostic accuracy or operational efficiency. Different incentives.
Okay. What else in economic context? Criticality.
Yeah. How bad would it be if this AI system just stopped working or went haywire?
Like power grids, air traffic control, emergency services.
Exactly. Essential services, public safety, major economic functions. The framework lists critical sectors, but also notes that not every AI within a critical sector is itself critical.
So the AI scheduling nurses' shifts in a hospital is important, but maybe less critical than the AI guiding robotic surgery.
Precisely. It's about the specific function's impact if disrupted. Systems deemed critical probably need much stricter testing, oversight, backup plans.
Makes sense. Then there's scale of deployment. Is it just a tiny pilot project?
Or used narrowly in one company, or broadly across an industry. Or is it like everywhere, across multiple sectors and countries?
Like facial recognition tech, maybe. It started niche, now it's pretty widespread.
Good example. The scale obviously affects the potential impact, positive or negative.
And finally, under economic context, technical maturity.
Yeah, they use TRL's, technology readiness levels. It's a scale from 1 to 9.
TRL1 is like basic idea on paper.
Pretty much. Basic principles observed. TRL9 means it's fully proven, operational, working reliably in the real world, like the tech in your smartphone.
So this tells us how developed the AI is, how ready for prime time.
Exactly. Is it still experimental, or is it a mature, robust technology?
Okay, dimension 3, data and input. This is all about what feeds the AI, right?
Spot on. What goes
Okay.
in? It starts with collection methods. How is the data gathered? By humans? Automated sensors? Or both?
Like in healthcare, a doctor entering patient notes is human collection.
Right. But a heart rate monitor constantly feeding data is automated. Often, it's a mix.
Then provenance. Where did the data actually come from?
This is crucial. Was it given by experts,
Hmm.
provided by users directly? Was it just observed behavior? Is it synthetic data made up by computers
Mm-hmm.
or derived from other data?
Observed
Yeah.
behavior, like how I browse a website.
Yeah, and the framework even gets granular there. Were you actively engaged on where data was collected? Or was it passive, maybe unanticipated collection? This has big privacy implications.
And synthetic data, why use that?
Oh, it's super useful when real data is scarce, expensive, or too sensitive to use, maybe for privacy reasons. You can generate artificial data to train the AI instead.
Interesting. Okay, what else about data? Its dynamic nature.
Is the data static, like a fixed historical data set? Or does it get updated sometimes? Or is it a constant real-time flow?
Like stock market data, always changing.
Exactly. This affects whether the AI needs to constantly adapt or if it can be trained once on a fixed set.
Then, rights associated with data. Is it company secrets, public info, or personal data?
Right. Proprietary, public, or personal. And if it's personal, that triggers a whole load of other questions, especially with regulations like GDPR.
Like how identifiable is it?
Precisely. Is it clearly linked to a person? Anonymized, so you can't link it back? Pseudonymized, where identifiers are replaced but could potentially be reversed? Or aggregated, like summary statistics?
And the less identifiable, generally the lower the privacy risk.
Generally, yes. Though true anonymization is harder than it sounds sometimes.
Then there's data quality and appropriateness. Just because you have data doesn't mean it's good data.
Absolutely critical. Is it accurate? Complete. Relevant to the task. Is it representative or is it biased? Does it have errors or noise? Garbage in, garbage out, right?
Still true for AI. And the structure of the data.
Yeah, is it unstructured, like free text, audio, video? Semi-structured, like emails or web pages with some tags? Structured, like a neat database table? Or complex structured, like knowledge graphs showing relationships?
Different AIs are better suited to different structures.
For sure. And related to that is the format. Is it in a standardized format, easy for different systems to read and use? Or some weird proprietary format?
Standardization helps with interoperability, sharing data, reusing models.
Big time. And lastly, they just briefly mentioned the scale. How much data are we talking about? Small data set or absolutely massive?
Okay, that's a really thorough look at the input side. Now for the engine room. AI model, dimension 4.
The brain, yeah. What's going on inside the AI? First is model information availability. Basically, how much do we actually know about how this model works? Is it a total black box?
Or can we peek inside? Crucial for transparency and trust.
Hugely. Then AI model types. The framework mentions symbolic AI based on rules, like logic.
That car engine production example they gave, if X then Y.
Exactly. Then statistical AI, that's most modern machine learning, learning patterns from data, and hybrid models that try to combine both.
Strengths of both worlds, potentially.
Potentially. It also distinguishes discriminative versus generative models.
Okay, what's that?
Discriminative models are classifiers. They learn to tell things apart, put them in categories, like identifying spam emails.
Okay.
Generative models create new stuff that looks like the data they were trained on. Think AI image generators or large language models writing text.
So one recognizes, the other creates. Got it. Though some systems probably do both.
Oh yeah, many modern systems are complex and might use both types. Which leads to the next point. Single or multiple models? Is it one core model doing the work or a whole interconnected system of models?
More models sounds more complex.
It can be. Harder to understand, maybe more places for things to go wrong unexpectedly.
How are these models actually built? Model building approaches.
Right. Is the knowledge coded in by humans, like symbolic AI? Or does it learn from data? If so, is the data labeled supervised, unlabeled, unsupervised, bit of both, semi-supervised? Does it learn by trial and error with rewards? Reinforcement learning.
Like how AlphaGo learned to play Go.
Exactly. That's reinforcement learning. Or maybe it combines learning from data with some human-provided knowledge too.
Okay. And once it's built and out there, does it keep learning model evolution in the field?
Yeah, does it stay static? Or does it keep adapting based on new data it sees or new interactions it has? This could be active learning, where it seeks feedback, or passive, just observing.
That has implications for maintenance, right? A model that keeps changing needs ongoing monitoring.
For sure. Which ties into model development and maintenance. Is this a general purpose model anyone could use? Is it customizable? Or is it totally bespoke, built for one specific user or task?
Who's responsible for updates, fixes, managing drift if it evolves? Depends on the model type.
Exactly. Then deterministic versus probabilistic.
Meaning,
Deterministic models.
yeah.
Same input always gives the exact same output, like a calculator. Probabilistic models incorporate randomness or uncertainty. Given the same input twice, you might get slightly different outputs based on probabilities.
Like a weather forecast model.
Good example. Most complex machine learning models have probabilistic elements. This affects how you test them and explain their outputs.
And finally, under model, they mention transparency and explainability again, specifically about the model's internal workings. Can we understand why it made a certain decision?
Which is a huge area of research and debate right now, especially for complex models.
Okay, deep breath. Final dimension. Task and output. What does the AI actually do?
Right, what's the job? The framework lists common tasks of the system. Things like recognition, identifying objects and images, understanding speech,
Event detection spotting anomalies, like fraud detection.
forecasting, predicting future trends, like sales or stock prices, personalization, tailoring content or recommendations,
Interaction support chatbots, virtual assistants.
goal-driven optimization, finding the best solution, like optimizing delivery routes,
Mm.
and reasoning with knowledge structures, using formal knowledge to draw conclusions.
And the framework points out policy issues tied to some tasks, right? Like bias in recognition systems.
Exactly. Or filter bubbles from personalization.
Mhm.
Or privacy concerns with event detection used for monitoring.
And often, AI systems combine tasks, don't they? Composite systems.
Yeah, very common. Like content generation needs language understanding, maybe image recognition and generation capabilities.
Hmm.
Or autonomous systems, cars, drones need perception, decision-making, control.
Monitoring and control systems too, like in industrial plants. And these composite systems bring their own challenges.
Definitely. Intellectual property for AI-generated content. Safety and liability for autonomous systems.
Then there's action autonomy level. How much does the human do versus the AI?
Is the AI just providing information, suggesting options, executing a task with human approval, or acting fully autonomously? That human-in-the-loop question?
Crucial for accountability. They also list core application areas, just broad categories like language tech, computer vision, robotics, automation.
Kind of grouping the tasks into wider fields. And lastly, evaluation methods. How do we actually measure if the AI's output is good? Is it accurate, reliable, fair, safe?
Lots of different metrics depending on the task and context.
Absolutely.
Okay, so those are the 5 dimensions. The framework also talks about AI in the lab versus in the field. What's that distinction about?
It's pretty intuitive. In the lab is the design and development phase, before it's deployed.
So focused on getting the data and input right, building and testing the AI model, defining the task and output.
Exactly. It's about anticipating problems, ensuring quality before release. In the field is after deployment, when it's actually being used in the real world.
And that's where all 5 dimensions really come into play, especially people and planet and economic context, because now you see the real impacts.
Right. It's about ongoing monitoring, managing risks that emerge, understanding the consequences, seeing how it evolves.
And this whole framework, these dimensions, they map onto the different stages of an AI's life, right? From
Right.
planning to junking it.
Yeah, the framework connects them to the typical AI lifecycle. Plan design, data collection, model building, testing, deployment, operation monitoring.
And why is that useful?
It helps identify who's responsible at each stage. The designers, the data providers, the model builders, the deployers, the operators, they all have roles to play in ensuring the AI is developed and used responsibly.
Okay. And they use this framework on some examples. You mentioned credit scoring and AlphaGo.
Yes, just briefly in the report, as illustrations, they showed how applying the 5 dimensions reveals just how fundamentally different those two systems are.
Credit scoring. Huge people and planet impact, operates in a critical economic context, finance, uses sensitive personal data. The model needs to be fair and explainable. The task is prediction with significant consequences.
Right. AlphaGo 0. Minimal direct people and planet impact. It's a game. Economic context is basically earned entertainment. Data is self-generated game data. Model is complex reinforcement learning. Tasks is optimization within game rules. Completely different profiles.
So the framework really helps tease apart those differences.
Yeah, exactly. It gives you that structured way to compare apples and oranges, or rather, different kinds of AI oranges.
So wrapping this up then, for someone listening, what's the big takeaway from digging into this OECD framework?
I think the main thing is empowerment, really. You now have a structured, a more nuanced way to think about any AI system you hear about or interact with?
Instead of just AI, you can think, okay, who uses it? Who's affected? What's the economic setting? What data does it use? How does the model work? What does it actually do?
Precisely. Those 5 dimensions, people and planet, economic context, data input, AI model, task and output,
Hmm.
they give you the tools to analyze it, to ask better questions, to move beyond the surface level hype.
Right. So here's a final thought for you to maybe mull over. You've got this framework now, this mental toolkit. Start applying it.
Yeah, try it out.
Look at the AI you encounter day to day, your social media feed, the navigation app on your phone, tools at work. How would you classify them using these 5 dimensions?
What does that classification reveal?
Yeah.
What are the potential issues or benefits that come into focus when you look at it through these different lenses?
Maybe pick one application that caught your interest during our chat and try to map it out. It's a great way to make this concrete.
Absolutely. By using this kind of structured thinking, you're really building your own understanding, becoming more informed, and hopefully feeling a bit less overwhelmed by it all.
Moving from feeling bombarded to feeling equipped.
Exactly.
Yeah.
Equipped to understand the technology that's increasingly shaping our world.